having a consortium together has given all of us a chance to really look into a little bit of a broader view of technology and computer vision and robotics, using cameras, just sort of standard color camera in an outdoor environment.
So here you see the camera rig that we have designed for the project. This camera system can, in real time, with actually quite little power, just a few watts of power, can in real time compute a full surround depth image and do that many times per second, get a full surround three-dimensional representation of the whole area around the robot. We build in special hardware here, in particular an FPGA, which is programmable hardware, which can directly and efficiently process all this imagery into depth images and extract also the imagery and pass it on to the next layers of the processing system.
Here at the University of Amsterdam, we created a synthetic dataset of more than 100,000 images, and we used this dataset to train a neural network. The dataset contained all kinds of garden objects like trees, pavement, rose bushes with ground truth and different imaging conditions. So over time, the neural network learned appearances of a tree of these different garden objects with an overall score of 92% accuracy, which is quite high. And the neural network not only obtained quite high accuracy for identifying the pixels in images, but also can be run in real time. Without this synthetic dataset, it's very hard to train a neural network because the ground truth as an outdoor scene, it's almost impossible. How do you get the lighting conditions from the sun, the direction, the spectral power distribution?
We in Wageningen, we have a lot of experience on how to deal with the natural environment and also how to build machinery and devices for that. So we try to incorporate this knowledge in the development of this device by selecting the right trimming tools, by selecting the right robotic arm and developing the motion algorithms for the arm to do these kind of manipulations. There are a lot of challenges here and, because we are dealing with non-rigid objects, we are manipulating them. The objects will look different after we have processed them than they have looked before, and that is all very different from classical industrial robotic applications.
We have a slight twist in the TrimBot project in the sense of that typically you make the implicit assumption that you're in a static scene, which we're not in a garden. And especially a robot that's designed to trim hedges, cut roses, is designed to change the garden, right? So this assumption that the scene is static is simply not true in our scenario. AI has given us a lot of new tools. We trained a network that would take geometry and semantic segmentation of an image as input, and then would learn how the underlying structure of the scene looks, even from only partial input. If you see a part of it, the machine is able to infer the rest of it, or at least have a plausible model. And this we couldn't do before deep learning really started to take off.
Everything needs to get put together, needs to be integrated in one system. So artificial intelligence plays a major role in TrimBot.
We as Bosch, we have a lot of experience in integration of things like that. We use one huge robotics framework, it's called Robot Operating System, and each partner has to contribute and use this framework and implement his algorithm in this framework.
So in addition to providing the mobile base hardware based on the Bosch Indego, we actually also are doing the navigation. So we basically make the robot go to where it needs to go. You can send him to a different bush or to a hedge, and we make him go there, and then it can start trimming.
Once the robot had its map and located itself in its environment, it finally had to detect the bush or rose and get into a position to trim a bush or prune a rose. At this stage, camera data can be challenging. Classic method can fail in textureless scenes. Here we use AI to improve the robustness and also the accuracy. And later we also use this for the robot-based camera, which also allows us to do visual surveying around the bush and also drive close to the bush.
These methods have essentially shown to outperform anything that existed before.
We've managed to integrate both novel computer vision technology and novel robotics technology together into a single platform and demonstrate all of this in an outdoor environment.
You know, the big challenge in the community is how far can we push things with just cameras?
We will see robots in the future. They understand the scene in the garden, they have the semantics, and they can decide what has to be done.
Trimbot has been a gardening robot, but 3D mapping and tracking technologies that developed here is not only for gardening robots. It can be also a story of autonomous driving. It could also be a part of AR/VR story. It's really an exciting time to be part of the research.